Hello and welcome back, and that's right, today we're going to look at 22 TB WD Red Pro drives in a 4-bay mid-range prosumer QNAP, and we're going to do some testing today over 10 gigabit Ethernet. We're going to look at a RAID 0 and a RAID 5 configuration, and we're going to do a series of tests to see several things. One, we want to see just how much performance difference there is between a RAID 0 and a RAID 5. Also, we want to see if it's possible for 4 of these 22 TB drives to saturate either fully or quite a lot a full 10 gigabit Ethernet connection. That is a 1000 megabytes per second connection externally on this NAS, which is slightly off camera right there, but you will be hearing its fans and the noise of the drives throughout this video. So I apologize, I'm going to try and dampen as much of that sound as possible, but there's just so much that's going to get through when I'm directly interfacing 10G on this device. But let me introduce you to today's contestants. So first and foremost, we have got the WD Red Pro NAS drive. It's a 22 TB drive, again, knocking around for about 600 quid in the UK. It's got 7200 RPM, and it's got 512 megabytes of cache there on board. It is a Pro Series drive there. If we look at the performance, it has a general performance rating of around 265 megabytes per second. Indeed, we can open up the downloadable product guide that will give us more information about each of the tiers. But if we scroll down to the bottom, we're able to see that this 22 TB drive has a reported 265 megabytes per second. And remember, 10G is 1000 megabytes per second. But thanks to something known as RAID, redundant array of independent disks, we are able to combine the performance of multiple drives, whilst in some cases giving ourselves a little bit of a safety net known as redundancy, and combine it all together to a much faster storage array. Which brings us to our next contestant, the QNAP. This is the QNAP TS-464. And this device is a 4-bay NAS system. If we have a look at the hardware, we're able to see that this 4-bay NAS system is powered by an Intel Celeron-based processor there, and it's got 4 gig of DDR4 memory inside. I've also upgraded this system, which already arrives with 2.5 gigabit Ethernet times 2 in ports there, so each one of those ports can give you up to 250 to 260 megs on their own, which would cover at least 2 of those drives. We've also installed a 10 gigabit Ethernet network card. This allows us to add a 10G connection to this device. So if we come out and go into the network settings, you're able to see there is our 10 GBE port there, and if we go to the list of interfaces, we can see our 10 gigabit Ethernet port right there. There's our IP 169.254.6.191, and at the top there is that IP. We're directly interfacing with that, and I'm pleased to say that we've already created our connection with this device. We've gone into the network settings of this, and within the configuration we've set the jumbo frames, or MTU, to 9000, which allows us to really open up the bandwidth of that connection there. Now, on my local machine, what I've done is attach a Thunderbolt to 10 GBE adapter. This allows us to utilize a Thunderbolt port on my local machine, which again you can hear because of the hum in the background, I apologize, but that allows us to add a 10 gigabit Ethernet connection to my local machine, and that 10 gigabit Ethernet connection can interface with the NAS also on 10G there. We've also opened up the jumbo frames on that up to 9000 as well. Indeed, if we make our way into it, we can have a little look, go into the configuration, go into advanced, go into jumbo packet, and boom, we're already set to 9000 as well there. So we've got plenty of performance to back us up there. Let's talk about some storage, shall we? Well, as you can see there, I've added a large amount of QNAP storage here on the screen, and this is our storage manager of our Windows machine. If we look into the QNAP itself, we can see that those 4 drives are there. We've got the list of all 4 of these 22 terabyte drives in this 4-bay system, and we've created ourselves a little RAID 0 storage pool there. That means no safety net, but it does allow us to combine all of that storage to a total of 88 terabytes of storage. Ignore the fact it says 80 TB there. That's due to the calculation between megabytes going into gigabytes, going into terabytes of 1024. Take my word for it, if we go into each one of these drives individually, they are 22 TB drives. It's about the calculation that's holding us back there. So, now we know we've got our RAID 0, and what I've done is on my local system created an iSCSI LUN. This is a blob of storage that can be utilized on a third-party operating system or server and be configured to have the appearance of local storage. Now, if we'd wanted to, we could have utilized a mapped network drive, which is very easy to add, going via the QFinder Pro application, and we can turn one of our shared folders into a mapped drive. But the problem with a mapped drive is it can't really be interfaced with the appearance of a local drive, like your C drive on your computer. And what you have instead on there, when you use an iSCSI target, is it then matches the visible architecture of, say, your OS drive or a connected storage drive. This allows you to use things like photo or video editing or other third-party tools on your local Windows or Mac system to interface with the NAS as if it was already connected, like a USB. And that's what we're going to utilize today while utilizing the software Atto Disk Benchmark, and we're going to run a series of Atto Disk Benchmark tests in order to test this. Now, these are from some tests I did earlier, so we're just going to get rid of all of those. And what I'm going to show you is one of the hurdles we're going to encounter in today's video, and that is that when we are doing our testing, if we're using screen recording software, much like we are right now, it has a tendency to harm our performance measurements. Sorry, I'm just trying to close these while I talk to you on camera and look at the screen at exactly the same time and making a bit of a pig's ear of it. But rather than edit that out, let's keep that in. For example, right now, I've on the QNAP NAS, via that storage area there and via the iSCSI manager, I've created a 20 terabyte storage LUN. And then I've utilized on there, if we look at that storage LUN there, we can find out more information about it. That is our storage area. I then use the iSCSI initiator tool for Windows to patch in to that drive. We're using a multipath setup there, so we can communicate with that drive natively. Now, on my local machine, I'm going to be using Atto Disk Benchmark. You may have seen a black screen there while Windows was asking for my permission. And if we drop down, we can see our RAID 0 of those drives there. You could ignore the RAID 5 element. It is a RAID 0 we're looking at there. It just happens to be the name. So ignore where it says RAID 5 there. And what we're going to do is run our first test. However, I'm going to need to do all of the tests off camera. The reason being that the screen recording software I'm using, OBS, that you see here right now, actually uses up a decent amount of system resources. And even with an internal GPU card, things like a Thunderbolt 10GPE adapter and screen recording software tends to make a real dent on our hardware resources being used there, whether you're using onboard integrated graphics or the GPU when we flick over to it in just a moment. So the consequence is that in order to make sure our results are as pure as possible, I have to do all of the testing off camera. Now, some of you may highlight why I'm not using a capture card like the one I'm holding here. Well, prior to this video, I was using the capture card in order to record a lot of the stuff for this video. However, even with the capture card, I saw a drop in some of the performance. So I took the decision to do the testing off screen and then go through all the results with you. So what we're going to do now is I'm going to run 5 individual tests on Atto Disk Benchmark on different file sizes using our targeted LUN that's in a RAID 0 configuration of those 22 TB drives. We're going to go through them and then we're going to format the QNAP to a RAID 5 so we can compare and contrast the results of all the different file formats connected over 10GBE versus a RAID 0 and a RAID 5. And what I'm going to do now is show you what would happen if I tried to do those tests with the screen recording software on, because I'm using a very small file format here, and what you'll notice is our performance is not going to be particularly good. The capture software running in tandem with the Thunderbolt resources being consumed are just going to be too hard going in order to get a relevant bench test of performance, because at the moment we're still interacting with my internal SSD as well as the external SSD, and the result is that the performance benchmarks we get end up being way less than we would like to see, and that's why I'm going to have to do the test off camera. But for now, what I'm going to do is cease recording, go through all of our testing results in just a moment. It's going to take me about an hour to run all of these tests with sufficient cooldown so we don't oversaturate the cache on the drives, and we'll go through those together before we move to RAID 5. Let's fast forward. Okay, so we've got our results, and I'll be straight with you, it was actually a great deal quicker than I thought it would be. I ran 5 tests in the end in Atto Disk Benchmark. Our first test, as you can see there on screen, was a 64 megabyte file over the 10 GBE connection, and we reached a height of 837 megabytes per second sequential read, and in terms of sequential write, we kind of lived in the 800s there, 800 to about 803 megabytes per second. And again, we could look at IOPS, but in this kind of context, when we're still using mechanical hard drives, even opening up the bandwidth of 10 GBE, IOPS aren't really going to be as applicable. Still good numbers nevertheless, they're reported on Atto Disk Benchmark. Next up, we moved on to a 256 megabyte file, so a quarter of a gig. And as you can see here, it still maintained the line quite well. We started to see a slight depreciation in write speed there, capping again at 803, but for the most part in the 7 and the 600s there. But it came to read, still largely saturating more than 2/3 of the 10 GBE connection there. And again, if we move on to our next, this is where we got into the gigabyte radius with a 1 gigabyte test file. And there we saw, again, nice consistent numbers, although we did see slight drops there as the cache on those drives was starting to get a little bit oversaturated there. Something that a lot of SSD testers can attribute to when we have those larger performance speeds. And when you have combined drives in a RAID configuration like this, and you're bombarding them quite heavily over 10 GBE, with high state tests like this, you do start to see the oversaturation of that cache become very clear indeed. And then we've got the next test, which is a 4 gigabyte test file there, and that 4 gigabyte test is where we started to really see the difference between the 10 GBE connection there, which is still, you know, going to be bottlenecked somewhat there, starting to hit a wall against that of the benchmark files we are testing there. 10 GBE or 1000 megabytes per second or a gigabyte means that becomes the bottleneck when we start looking at these bigger files, and then the transition of that speed becomes a case of system handling versus the presentation and the delivery of that data there. But again, we saw performance there in the 6, 7 and even early 800s. And then finally, we can have a little look at our biggest test file there, which is a 16 gigabyte test file over the 10 GBE iSCSI target there. And again, we saw the 7 to 800s, again, more than 3/4, close to, you know, getting quite high into fully saturating the 10 GBE, but in the RAID 0, we never quite hit the mark there. Now, that may be because of the Celeron architecture. If we were using something like a Xeon or maybe some of the AMDs with a larger thread count, then we might have seen a little bit more handling of that floating point there. But still, great numbers here from these 22 TB drives. What I'm going to do now is I'm going to rebuild this RAID array, and this time I'm going to be moving into a RAID 5, repeating all of these tests in the RAID 5 environment, and then from there we're going to compare the results of the RAID 0 versus the RAID 5 on the 22 TB drives. That's probably going to take me more than a day, to be honest, because the RAID 5 on drives of this scale is going to take an exceptionally large amount of time. So you can have a little look on the corner of the screen what the date is there for when we carry on and look at the results of the RAID 5 testing. Let's fast forward. Okay, so we're back on the desktop with our QNAP NAS. Apologies for the fan noise in the background. I'll give you a slight explanation in a moment about that. But as you can see right now, if I zoom to the bottom right there, I don't know how much you're going to see with my camera in the corner there, but right now it is 11:58 AM on the 14th of September, and we'll come back onto the desktop there. Now, our RAID 5 has not finished rebuilding, which is super annoying there for us because I've only got these drives on a very short loan. So unfortunately, I've had to conduct the rest of the tests during resynchronization. So I just wanted to add this disclaimer early doors. If we go into the storage area there, you can see our RAID 5 has been initialized, and if we make our way into the RAID group, there is our RAID 5, and there is that 60 TB, again mathematically across the 22 TB drives inside, already completed there. And if we can make our way into the storage and snapshots there, you can see I've already recreated our iSCSI target and LUN there, and on top of that we have got that storage area being played with. However, synchronization is taking place now. A number of users no doubt will highlight to me that we could have resynchronized at a faster speed. You can go through some of the settings in order to reshape the resynchronization, but due to the size of 22 TB drives, this was still going to take the better part of a day and a half, and I still want to include RAID 6 in this video as well later on. So what I've done is take the decision here to lower the resync down to low speed for now, and what I'm going to do is I've performed these tests, but with the caveat that it is worth highlighting that if you do have a fully synchronized RAID area, then you would normally get an increase of about 5% on that performance there. So if you are going to performance test your QNAP with drives like this, do bear in mind that you should really wait until the synchronization is completed, which, as you can see at low sync speed, is still going to take another whole day, which is longer than I've got these drives on alone from WD, unfortunately. So what we're going to do now is, again, I've had to reboot the system. I did a reinitialization and the IP has changed, so I had to rebuild all of those bits there in the background. So as you can see, I've re-added the drive with the 4 WD drives there, and I reinitiated the iSCSI target there on our new IP, and on top of that we've got the drive already connected there on our system, so we can go straight into the My PC area, and boom, there we are on screen. So while we do that, it's also worth highlighting as we go through the results that we've still got the results from the testing I performed yesterday, or a handful of minutes ago for you guys, that details all of those performance benchmarks that we had with the RAID 0 configuration there, which we're going to be going through in just a moment. But for now, we can make our way into the results that I got from doing the tests in the RAID 5, running the exact same test setup. So this is the 64 meg, 256 meg and 1 gigabyte file test there, and as you can see, we're getting performance numbers. They're a little lower than what we saw in that RAID 0 now. Yes, we do have to factor in the resynchronization, but still, nonetheless, if we bring up our results from earlier and we put them side by side, let's close that one there, we only need the one there on screen, and we compare first and foremost that 64 meg test file there, we can see, bringing them side by side, the performance difference there was, again, more than 100 to 150 megabytes per second higher in the RAID 0, kind of what we expected to see in this configuration and with this CPU. And that is predominantly in the read speed. In write speed, when we put them side by side, the difference was notably smaller, because write speed had already kind of hit capacity to a degree, and if you were removing the initialization factor, maybe those numbers would have been a pinch closer together. And if we make our way into the other test there, and this time bring side by side the 256 meg, quarter of a gigabyte file there, bring those side by side as well. Again, we see a clear advantage there in terms of read performance in the RAID 0 versus the RAID 5 with these drives in this 10 GBE setup. But again, now we're starting to see that write performance start to dip notably because of the parity needed to be built in a RAID 5 configuration alongside that of the 22 TB drives and that large amount of data and the 256 megabyte test file. Even without RAID resynchronization there in the background, we still would have seen numbers not dissimilar to this with a very small margin of difference between them. And then finally, we can talk about the 1 gigabyte test file there. This is when we make our way into the 1 gig test region. And again, we see read performance there notably higher on the RAID 0, whereas write performance, we're really starting to see that performance dip. Now, again, I say performance dip, we're still talking about just simple mechanical hard drives there running side by side and still reaching over half saturation of a 10 gigabyte test file there, of a 10 GBE network connection on a 1 gig. So we're maxing and saturating with the file format alone to still give us more than half the full saturation of extended write operations. Now, if we make our way into the greater than gigabit connections, and these are our 4 gig and 16 gig test files there, we can see that we kind of find the level. We're able to half saturate the 10 GBE, but we may be reaching the point where 10 GBE and these drives mixed together when we're dealing with greater than gigabit files on a sequential test starts to meet its match, and it's only read that becomes a notable area where we can make distinctions between these drives. So if we look at the 4 gigabyte test with the RAID 0 on the right and the RAID 5 on the left and bring those side by side, we're able to see again the read performance still continues to be high, but this is where we started to see the write performance get a lot more throttled on the RAID 0, and that's something we've seen happening there on the RAID 5 configuration as well between the two of them. Still markedly higher in RAID 0 throughput there because the additional calculation as data is being pushed through that 10 gigabit bandwidth there. The data being passed through still needs to be manhandled and the parity calculated on the RAID 5 in a way that the RAID 0 doesn't need to do, and that's why when we look at these side by side we're seeing in some cases 2 to 250 megabytes per second give or take difference in write performance there, and that was again something we continued to see once we hit the top end of the spectrum there and went side by side. Let's bring that back up there. Decided everything to go crazy town there, but you know what, we're just going to persevere. I'm not even going to cut this from the original from the video for you guys, and we can put those side by side there, and as we can see moving into the larger 16 gig test file, that again we're seeing that enormous difference exceeding that of 1 to 250 megabytes per second difference at a number of these tiers. But in terms of the read performance, we start to see that change and that matching there because we were getting into the larger 16 gig test file for both. Look at the read performance parity between the two of those. That's the closest we've seen a RAID 5 and a RAID 0 performance threshold, because even with or without the parity there, we're at a point where the oversaturation of a 10 gigabit Ethernet connection is clearly being reached. So what we're going to do now is, for the final stage of this video, we are going to format to a RAID 6, because I'm sure a number of you will want to know the performance difference with drives like this and 10 gigabit Ethernet in RAID 5 and RAID 6 difference between them. Because it's one thing to say RAID 0 versus RAID 5, there's going to be performance versus parity differences, and therefore recovery with that redundancy, but at the same time when it comes to a RAID 5 versus a RAID 6, then it has to be said that there is that safety net versus performance in a new way with 2 drive failure rate versus failure protection versus 1. So what we're going to do is just completely reformat the system. I'm going to slowly but surely remove all of our connections. So again, disconnect that iSCSI connection, and what I'm going to do is bring you guys back later on to when this is formatted. It's probably going to be tomorrow again. So let's disconnect from that available iSCSI there. That's going to disconnect our drive, and then from there I'm simply going to make our way into the QNAP and just format. That's Windows telling us that it's lost connectivity with that drive, and then all I'm going to do is format this system right the way back to factory settings and build ourselves that RAID 6 configuration. And I'm going to either bring this back to you guys tomorrow or later on with the resynchronization there in place, and we're going to see how the RAID 5 and the RAID 6 configurations using these 22 TB drives over 10 gigabit Ethernet compare in terms of performance. Let's go. Okay, so once again we are back and we are on our RAID 6 configuration. There it is on the bottom of the screen, the RAID 6 there. Once again, of course, due to time constraints already discussed, unfortunately synchronization is still something that's taking place here on this storage. Now again, if we do look at the synchronization, how long it's going to take, we've got 65 hours, which is longer than I've got these drives for, but I've still managed to conduct all of our tests, and hopefully that will still keep things relative to the RAID 5 that we discussed earlier on. So again, we've created our iSCSI target and LUN once again on this fresh installation of QTS. We've already attached it to my local system. Again, iSCSI target, blah blah blah, added the drive, etc, etc. We're all connected, so why don't we go through those results, shall we? Well, straight away, again, we are going with Atto. We're going with the exact same layout that we had before. First thing we'll look at there is the 64 meg, 256 meg and 1 gig test, and as you can see, this is where, because of the RAID 6 double parity architecture, we started to see write more than anything take an absolute kicking, but we really started to see read drop a little bit there. Now again, there's nothing negative about the NAS, nothing negative about the WD drives. It's simply that RAID 6 is where things do get serious, and even though we have made enormous advances in RAID creation and efficiency with CPUs, RAID 6 still manages to be particularly tough, especially when you go to these larger file types there. So as you can see, we're looking at speeds around up the high 700s there across all three in terms of read, and when we look at write speeds, we really started gutterballing down to the 300 and 400 megs there because of the larger amount of data. And it was when we went to the oversaturation of the gigabyte files, which you'll also see in the 4 and 16 gig files shortly, that we started to see that write performance really drop, and that's when we have to start looking at 8 or even 12 bay enclosures with drives of this caliber. Comparing against the results earlier on with the RAID 5 that we had just before we did our format, do show the distinct differences between the RAID 5 and RAID 6 configuration on this system and those 22 TB drives. To put it into perspective, if we open up the 64 megabyte test file there and remove the file there, so let's bring them side by side, we can look at the 64 meg side by side. So this time we are running the RAID 5 on the left versus the the RAID 6 on the left versus the RAID 5 on the right, and we can see there that the read speed was fairly consistent in both cases, but it was when we were looking at the write speed that even on this small file format of 64 megabytes that we saw certain trades off there between the two of these in terms of performance, as the parity is having to work with these different formats as well with each repeated test. So again, if we move away from that and go into the the 256 megabyte RAID 5 file there, so we'll bring that, and again the RAID 6 here on the left, and we put those side by side. Again, this is where we start to see that big change in write performance. Read performance still living in the late 700 megabytes. In terms of write, this is where I don't think at any point, no we didn't even break into 400 megs once there, whereas in the RAID 5 we comfortably broke 400 megs and even into the 500 megs there. And again, this is a trend that you will see continue as we move forward. If we go into the 1 gigabyte test file there, we'll bring up that test there, bring it up, wallop done. Left hand side here is our RAID 6. We pop those side by side, and again, no overlap needed there. If we have a look, again, still sitting in the 700 megs or so, still absolutely fine, but it's looking at the write performance. We're still seeing that difference with the RAID 5 versus the RAID 6 of around about 100 to, in some cases, 120 megabytes per second change there between them, which again is at another marked decline there. And I mentioned at the start of the video about when you're in a RAID configuration and the performance as you add more drives is generally around about 70 to 120 megabytes per second, depending on the quality of the drives and the CPU and the RAID. And we're seeing that played out in the RAID 0 versus RAID 5 versus RAID 6 comparison there. So now we'll go for the final two. These are our plus gigabyte files there. So we've got the 4 gig and the 16 gig there. On the right hand side of the screen here, this is where we're going to bring in the 4 gig file there. So we'll bring those side by side. And again, left hand side RAID 6, right hand side RAID 5. And again, this was where, because we had exceeded or at least hit the 1 gigabyte file size on Atto, we could see that performance there. Still higher on the RAID 5, of course, still crossing into the half of that gigabit connection, but at the same time, or I say gigabyte connection even, but it was in terms of the write that we started to see parity between them as that oversaturation of the connection. And whereas before we saw that 100 to 120 megabyte difference, that margin becomes thinner at each tier. We do still see that 100 meg difference, but not as notably and throughout the entire graph. And finally, we can look at our biggest file there, the 16 gig file, which again, as we bring them side by side, we can see again, RAID 6 here on the left, we can see that was 400 to about 450 across the board on both read and write with the RAID 6, whereas in the RAID 5 we could see it's still living 100 or so megs higher. And that really is the marked difference between the different RAID configurations. A lot of users, when they buy either fast hard drives or SSDs or enterprise level hard drives or SSDs, will often say, well, I did my RAID 6 for all my redundancy, why am I not getting the performance? That's why you're not getting the performance, because of the extra workload that a RAID 5 or indeed a RAID 6 does bring into the mix. It's been largely negated in recent years, but nowhere near as much as many of us would hope. And also, don't overlook that the CPU inside this device was a quad-core Celeron, which is great for graphical capabilities, but when it comes to file management, it's still not going to give you as much as a lot of some such as the AMD embedded Ryzen series or an Intel Xeon CPUs that are far more based on faster file transit and also those additional threads working with the cores, which can of course be used for other things. But when it comes to file transition, they will always win. And when I've tested these drives in this configuration in a RAID 5 in other systems that have run more file transition and file processing CPUs, we have seen it hit the 1000 megabytes per second. Our Synology testing, for example, we maximized and completely saturated our 10G connection in almost all of our tests when using a CPU that was more based on file transition. But this has been testing the WD Red 22TB WD Red Pro hard drives in the QNAP TS-464. I hope you enjoyed this. I know it's been a long, arduous, techie video. It's taken me about 3 days to film this video, and I hope this does help someone out there. I know this is a spectacularly niche video, but I know there are people out there that love this sort of stuff, so this is there for you guys. Click like if you were one of those people. Click subscribe as we do more videos like this and cover this subject, as well as celebrating 10 years of WD Red here on the channel. And if you want to learn more or need some advice on your setup, then do go into the description below and use the free advice section over on NAS Compares, the article that is going to be breaking down all of these performance results along with all of the screenshots we've taken, and use the free community forum Ask NAS Compares, made by me, Eddie, and the NAS community to answer your questions. But otherwise, thank you so much for watching, and I'll see you next time.